This video tutorial is going to outline the workflow used when using the Adapt Integration Console. And in this workflow, we're going to be using Etabs version 2016. And we have a multi-story structure that we want to import into Adapt Builder version 2016.2. We want to add foundations at the base of the structure and use a simplified approach, which is the Tributary load takedown approach, to collect reactions from a gravity standpoint and analyze the foundation. We're going to go ahead and start. So we just have an image here of the structure that we're going to be using today. It's 60 plus story structure, and in the Etabs model, under the load definitions, we have several loads including both gravity and lateral load cases that are defined: dead, live, roof live, superimposed dead, facade load. We also have several static wind load cases and also earthquake load cases. We're going to ignore the lateral for this particular example. We're going to focus on sizing or being able to evaluate the foundation relative to the gravity loads for preliminary purposes. And so we'll go ahead and just cancel out of that. So we have our model that's been built in Etabs mainly for the purpose of lateral load analysis, but we can access and use this model using the Adapt Integration Console. So I'll go ahead and I'll close this model. And I'm going to launch the Adapt Integration Console. And at the top, we have the ability to then select the program that we're going to be using. We're going to be using Etabs, using the API. We'll select Next, and in the next dialog window that opens, we want to select the EDB file that we're going to use and access the data for that Etabs file, and this helps us write an input file that will be used in Builder. Using the Browse button, we're going to select the City Tower model, and then we're going to select the option for creating an Adapt Exchange file. You'll notice that I've left off the selection of this box, which allows us to extract reactions relative to the load cases in Etabs. We're just going to leave that alone for now. That doesn't apply to this workflow, and we'll go ahead and create this exchange file. When we use the option to create the exchange file, the program will launch Etabs, so you have to have an active license of Etabs available. It will launch Etabs to access the API and extract the information needed. After the integration console has completed writing the file, there will be a message that will appear on your screen that shows us that the process has been completed. Depending on how large the model is, this may take up to several minutes to complete. But we can see that we have a successful message that appears. We'll select OK. And we'll just go ahead and close the link. We're now going to navigate to the folder where the Etabs file was stored, and we can see now that we have an IMP file that is an Adapt Exchange file that's written that we'll be able to access inside of Builder. So we'll go ahead and launch Builder 2016. In this case, we're going to turn the edge on. We really don't need MAT or SOG, but we want to have Edge and, let's say, Floor Pro turned on in order to access tools within the program that might be useful when we're designing and analyzing the multi-story frame. So we'll select OK, and we're going to navigate to File, Import, Generic Adapt File. We'll go back to the location where we stored the file, and we now are going to open and launch this IMP file. When we select that file, we're going to have the import options dialog appear. And the first thing we'll do is go ahead and select all levels. We're going to import all levels in this case. This will give us an indication of the number of components being imported. We have several beams, columns, walls, slabs, etc. And also we have the ability to either update an existing model or create a new model. In this case, we want to create a new model from scratch using these import options. We're going to import some load cases. So for live roof live, superimposed dead, and facade, we're going to import only the applied forces. For everything else, we want to set that to none. So I will just use this option for import none. I'll go back, and for each of my gravity loads, let me just go ahead and stretch this out so we can read that. We're going to select applied force only. This will import the applied loading for each of these load cases. And we want to map these to existing load case names. By default, when we launch Builder, we have dead load, live load, self-weight, pre-stressing, etc. that's included. So if we go back and look at the load case names out of Etabs, we have live, roof live, superimposed dead, facade. We're just going to use those names as they are and create new load cases inside of Builder that include these names that stem from the Etabs model. So we're not going to map any of the loads. We're going to also go to load combinations and select the option to import none of the load combinations. And then we'll go ahead and select OK, and the model will be constructed based on that input file. And we can see here that there's a beam width initialization error. This just means that one of the beam's widths is less than the minimum tolerance within Builder. So we'll just go ahead and say OK, bypass that. We can see more loads are being populated for the model. And the final result looks like this. This is showing us the geometry, all of the components, as well as all of the applied loads for those gravity load cases that we had imported. We'll go ahead and turn off a few of the toolbars here. If I go to the Select Set View Items tab under Loads, you can see we have multiple loads which were imported, and they're also being viewed. That's a default when we import from the IMP dialog. I'll turn those loads off, so all we're left with will be the geometry. We can see a plan view. We're in multi-story view, looking top plan view, looking down on the building. And one other thing to note, under loading load case library, we can see that those load cases that were imported have been included as general loads under this tab when we bring those into this model. So those are now listed. They can be used to create combinations and evaluate those combinations. So we'll go to a rendered view so we can just navigate and see what this model looks like. We can see it's a pretty large building, several stories, and we're going to now use this model for a specific workflow. The model at this point could be validated. We could mesh the model. We could run this from a finite element perspective, but we're going to use this using our tributary load approach for the sole purpose of sizing a mat foundation at the base of the structure. And so we'll go ahead and just navigate to the bottom of the building. I'm going to use my level assignment tool. I'll go down to base, set this as my active plane, and now we're down towards the base of the building. And I'll just put in an arbitrary mat. We'll just go ahead and create it using the build slab tool. And this could be a series of spread footings, it could be spot footings, it could be any foundation that you want to model in the program. In this case, for this example, we're just using a thick mat foundation that every vertical support bears on. So we'll go ahead and make this foundation, we're going to say 600 millimeters deep. And here in the core area where we have the core walls coming down, I'm actually going to create a new slab there, and we will create, if we zoom in a bit, we can kind of see the dimension. This is roughly 22, 23 feet. We'll make it about 20 feet wide, and using the dynamic dimensions we can read that dimension, but we'll go ahead and make this internal piece 1,000 millimeters thick. So if I just take a section cut through this frame, we can now look and see what this looks like. So we have our 600 millimeter thick slab that steps down to 1,000. We have several columns that are being bearing on that, plus the walls. So if I take another section cut just through the wall elements, we can see this is what that looks like. I'll get rid of those. So we have our footings in place, or our mat foundation in place. We're now going to define a spring, an area spring that is essentially the soil that these mats are sitting on. So we'll go to Build, Spring, Area Spring. I'll go ahead and just add a spring here. And if we double click on the spring, we can enter the Properties menu. We'll say this is a compression only spring with some value for the bulk modulus of the soil. In the Z direction, we'll just leave the default as is. And we've now established the actual level that we're going to analyze using finite elements. But this is the only level that we're really going to access that engine in within Builder. So I'll go ahead and just go back to my multi-story view. I need to get loads down to that level. So one of the most efficient and easiest ways to get loads down to the base level is to use the Tributary Load Takedown tool. So we'll access that from the loading tool, or the loading menu. We'll go to Tributary Loads. The loading dialog box will appear, and we're going to generate tributary regions for each of the vertical components transferring down through the building to the mat foundation. We're going to first select Regenerate the Tributaries, and the program will create a tributary region for each of the vertical components, including the sloping components like the braces at the top of the structure. There are several levels where we have some sloping columns. We can see as this is working, we see the red outline at each level. Those are just the tributary boundaries which are being populated and created from bottom to top in the structure. So this is nearing completion as we get closer to the top of the structure. If there are any transfer conditions where you might have a column transferring on a slab, or a column onto a beam, or even a column to a column if they're not concentric and they're offset, all of the transfer conditions are listed in this transfer dialog window. So for example, if we go and just select one of these, it will take us directly to that transfer location. If I go to a plan view and I look at this particular instance, we can see that this strut, or this brace, is transferring load from this point down to this point, and the program shows us where those transfer conditions occur. We have a series of those transfers at this level shown here. It might be easier if we look at this in a three-dimensional format, and you can clearly see that we have some bracing that's happening that's requiring the load transfer to go from the brace down to one of these perimeter columns or this interior location. Once we've created the tributaries, we're going to create the load takedown. So I'll go back to my multi-story view, and I close that dialog for the tributary, but we'll reopen that, and the tributaries will still be shown. We can see all of the tributaries stacked in the model. We'll just go to recalculate the loads in order to establish the load takedown. And again, depending on the size of the model, this may take a few minutes, but it's a relatively short amount of time for this to be calculated. So that's been completed. We'll now close the dialog menu, and we will navigate over to single level mode. I'll go up to the top floor of the structure. We can get a idea of what these tributaries might look like. Let's make sure we select this as active plane. And using the result display settings window, this is what we call the red eyeglasses informally. This is going to allow us to now check the tributary regions with load takedown, either level loads or cumulative loads. And we can see for each of the components we have some tributary region associated with it. For example, this column, this is our tributary region here. We have the ability to check either the level tributary along with the facade length, which is the perimeter of the slab, along that location where the area is bounding that support. We can also look at the cumulative area and cumulative loads, for example. So this just shows us that information for each of the supports. And we could work our way down the building reviewing those accumulation of forces. So ultimately we want to design that foundation that we added towards the base of the building. So I'll navigate to the first elevated floor, which is called Story 1. We'll set that as active. And if we look at the cumulative loads for this particular level, these are the loads that will be assigned, or let's say placed on the mat foundation when we analyze this. We can see, for example, this column has a series of facade live, roof live, and superimposed dead loads, also self-weight, that are associated with it. And this is in metric, these are in kilonewtons. Each one of those supports at the base of the building, including the walls, has an assignment of reaction. Let's just, for example, take this wall. The reactions are shown here. We have reactions for this perimeter wall here, which would be applied at the centroid of that wall on the foundation. So we have the tributary reactions in place. I'll navigate now one more level down to the mat foundation. I'm going to mesh the mat, and I'll just use a 1 meter mesh size for this mat. And if I go to a three-dimensional view, we can see we're only analyzing one level at the base of the structure. We're ignoring the entire frame. We have those loads in the columns and the walls that we can apply to the mat now. And we'll go now to FEM, analyze the structure. We're going to analyze this just for the default load combinations, which are gravity oriented. And I'm going to use the option for include load takedown. This applies to gravity loads, and the gravity load takedown that we're going to introduce shows us that we have only self-weight. It doesn't show the loads that were imported from Etabs, and the reason for that is the combinations that we have defaulted to include the predefined load case names in Builder. We have to add the load case names that stem from Etabs. So we'll go ahead and cancel that and go back to loading combinations. And we just need to do a little bit of work on the combos. This is pretty easy to handle. We'll go in and rearrange some of the factors for each of these combos. So for example, for service total load, we're going to add 1 to live load from Etabs, 1 to RLL, 1 to SDL, and 1 to facade. And I'll delete the dead load and the live load just to avoid confusion. There's no load that is actually assigned to those load cases, so there would be no harm in keeping the factor. But if someone was to come and review these combinations, they may have questions about why there are 2 superimposed dead and live loads included in the same combo. So we'll get rid of those. And now we'll come here and just add some factors to the loads that were brought over from Etabs. And here we'll use 1.2. I'm essentially using the same factors for the new load cases. Delete that and that. And then this will include only 1.4 times the superimposed dead load, 1.4 times the facade load. So we have self-weight also for that individual mat at the base. We'll say OK, and going back to the Analyze options, when I now click on Include Load Takedown, now it lists all of the load cases that are assigned to load combinations that have been selected. We have the ability to go into any of the load cases and select our source for the reactions. In this case, our source is just Tributary. That's all we've used thus far. We haven't run the model from an FEM perspective. We haven't even meshed the entire model. We're just using the vertical loads based on Tributary. Once we have our load cases defined, our solutions, the reactions will be in the Z direction, and we'll go ahead and analyze this mat with these reactions stemming from Tributary load takedown. The program will now run through that analysis using our frame solver, and this shows us the node count, the frame elements, the shell number of shell elements. And again, for this particular workflow, this is a very reasonable and practical approach because we eliminate the need to solve for an entire frame, which might take a considerable amount of time and much more than it would just modeling and analyzing this one level that we're really interested in. So the analysis has been completed after just a few minutes, and we can now access results for this mat with consideration of the loads stacking on the foundation. I'll go ahead and just navigate to a clean view of the structure in top plan, and let's say we want to produce the soil pressure contour for this foundation. So we'll go select the load combination in question. In this case, we'll just use the total service load. We'll navigate up to the slab results for soil pressure, and then we can see the soil pressure map for this particular foundation. And this allows us then to determine the feasibility of whether or not the applied loads to the soil will work given the strength or the characteristics of the soil. We can also navigate to the view analysis results, the add viewer, the AD viewer, and check the deformed shape. So the global translation for this particular foundation system, if we were to show this, we can see that particular system in the deformed view, and that can be done for any of the directions. This will also give us an image of the global displacements for the foundation. If you have any questions about this video, please contact support@adaptsoft.com. Thank you.